we will go ahead and let Ryan Kenney talk, and he'll introduce himself and talk about cloud CI versus self-hosted CI options. So away we go.
Awesome. Thanks, Gene. Let me share. Go to Google Chrome. You can see my nice presentation, all my many tabs. All right. And you guys should still see my screen now? Just the slides? Everything good? All right, cool. Yeah, like Gene said, my name's Ryan Kenney. I'm a senior DevOps engineer at Storyblocks. Unfortunately, we're not hiring at the moment, but probably going to have some openings in the fall, so I'll keep you all posted when those show up. Anyways, as the title implies, we're going to be doing sort of a high-level overview of cloud CI versus self-hosted CI, looking at some options, seeing what the difference is between them are, pros, cons, that sort of thing. 30 minutes really isn't a lot of time to talk about that, but I had to cut this down from it was an hour talk to just 30 minutes, so did the best I could. We'll go into any detail on areas that y'all care about, and I set aside some time at the end for open discussion, hoping we can make it to that. That said, if there are burning questions or anything, feel free to interrupt me and I'll figure out how to adjust time that way. So anyways, away we go. First thing to do is just define some terms since the title uses a bunch of overloaded things. So CI, continuous integration, it's a development process where we continuously integrate code, hence the name, into a mainline code base. Depending on the nature of an application, you might be compiling code, building a Docker image. A lot of y'all are using Docker, packaging up assets. Your CI process is probably testing and doing static analysis as well. In the spirit of overloading terms, we also use this term very closely with the tools by which we implement continuous integration. So a lot of times we just use CI as shorthand for the tool itself and not the process. So next, self-hosted. This just refers to running something yourself instead of having someone else do it. So managing hardware, VMs, software. Again, in the context of this talk, we care about self-hosted software. Again, the CI. Cloud. Now that is an overused and overloaded buzzword if there ever was one. The cloud simply refers to the internet and specifically resources that are available in it. So like for consumers, the cloud to them is like storage. So they store their music and photos and game saves, whereas to us, the cloud is, we think of cloud providers. So they supply things like computation power, networking, storage too, serverless functionality, stuff like that. More broadly, you can think of it as something being provided as a service. In this case, the something we care about is our CI tool or software. Again, SaaS, just making sure we're on the same page, pretty self-explanatory. Someone else manages software, you use it, you give them money to do it. Sometimes there's free tier stuff, but again, it's meant to drive business. So those are just some of the terms that we're using, just making sure we're all on the same page. So then the next piece is, well, why is this decision important? I'm going to skip the part where I would have to convince you that continuous integration is good and that it's important to Agile, probably a safe assumption, but if anyone disagrees, we can talk after. So then the next thing is, why do we care what tool we pick or whether it's self-hosted or cloud or what have you? Is this important enough to listen to me drone on 30 minutes about it? And I'd like to tell you why the answer is yes. Your CI tool is very versatile, very impactful. It's in charge of how you build, test, secure, and in many cases deploy your application. So for full feature tools, like if you're using Jenkins, you might use it as a jump board to other tools and other dashboards. You might use it itself for dashboarding. Now that said, the reach that a tool has doesn't make it particularly important by itself. So like the cloud provider you pick maybe isn't important for all organizations, right? Like whether you go with AWS or whether you go with GCP, you may not care. So in the cloud provider you pick impacts your entire infrastructure. The difference between CI tools and cloud platforms in this regard is the disparity of features. So where there's a disparity of features, there's a difference in what you can create in the processes that you build. There's something called the law of the instrument, also called the golden hammer, which is why I have this picture of a RuneScape golden hammer. But effectively, it's a cognitive bias, which says that the tools that we favor tools we're more familiar with, which then affects how we problem solve. And so this comes from the "to one with a hammer, everything looks like a nail" cliche. It's from that family. So, here we're just talking about the familiarity. Instead of it being the familiarity with the tool forcing us into a box, it's just the nature of the tool itself. So this is why picking the tool is actually very important. And then perhaps most importantly, cost to run your business. So there's a bunch of different costs, like how much does the tool itself cost? How much does the infrastructure cost if I'm self-hosting? How much do we pay in maintenance? Do we pay in maintenance? How much time does it cost to learn? How much time does it cost to integrate new features? And all of these questions are going to be important for not just determining whether you want to go cloud or self-hosted, but which particular tool in those families you want to pick. So without further ado, let's take a look at Cloud CI first. So I decided to break things apart. There's a bunch of different ways. Initially, I just had a glob of icons here, and we were just going to go through and talk about each one. But there's different patterns, right? Like what the payment model is, what the base feature set is, what the extended features are. But I decided to break it down by the most discriminating. So on the left-hand side, we have the ones that are Git provider specific. So if you use GitLab, you might use GitLab CI. That's the first one here. If you use Bitbucket pipelines, you use, if you use Bitbucket, you might use Bitbucket pipelines. That's the lower one. If you're using GitHub, you wouldn't use either of those. So a good way to filter out tools you won't use is, the ones that are specifically for a certain Git provider. That said, looking at GitLab CI a little closer, it's actually kind of interesting. So a lot of these tools, you just give them more money and they give you more execution time. GitLab CI actually has, at some of the higher tiers of pay, you get things like a container registry. So, maybe you were using Docker Hub or you had an ECR registry in Amazon. You don't have to do that. You get it with GitLab CI, and you don't have to worry about authenticating or anything because it's all sort of integrated into one package. At the top payment tier, you get SAST, or Static Application Security Testing. So, that's pretty remarkable considering most CI tools generally rely on other tools to do that type of scanning. So GitLab CI is trying to really make their CI arsenal worth the money. Now, GitLab CI is also an oddball because while it's a service, it's also a product, meaning you can run GitLab CI yourself, making it, you guessed, a self-hosted option as well. So while it may upset the cloud purists, I still consider it a cloud option as well as a self-hosted option. So we're going to see it in both categories. Bitbucket pipelines, not going to show it as much love. It's a fine tool. I've used it a few times. They focus a lot more on their CD capabilities than they do their extensive CI set. So it's just the way they decide to market their tool and differentiate. So looking at the next column, we're looking at some of our cloud provider specific options. So you may recognize the random assortment of rectangles as an AWS tool. This is AWS Code Pipeline. That's kind of what all their logos look like. They're not very imaginative. And then the rocket below it is Azure DevOps. AWS actually has a suite of services for building and deploying, and Code Pipeline just wraps them all up into a singular interface. Azure DevOps kind of does the same thing, except they're a bit more ambitious with what they try to do. So they thought they have an artifact repository in the suite, and they have an agile planning board. So they're kind of trying to go the Atlassian route, where you have this suite of tools all by one company with a product for most major software needs, all benefiting from the well-known and reputable brand. Well, Microsoft is well known. I'm not sure about how reputable they are, but regardless, that's kind of the route they're going. So it'll be interesting to see how they go there. Honorable mention, again, I didn't post every logo I know of because then that's all the screen would be, but Google has Cloud Build. That's the GCP equivalent. If you want a cloud specific CI tool, you would use that if you're using GCP. It doesn't really do anything crazy, not a lot to talk about there. And then in our last group, we have just some of the more popular or long-lived agnostic tools. So we've got Travis up top, and then Circle CI down here at the bottom. So I've worked a lot with Circle CI, played a bit with Drone. It's not pictured here. I heard y'all talking about it before. And then Travis, a bit of Travis back in the day. The nice thing about these is you can use them with any of your cloud providers and get products. They tend to be a bit more, they tend to be a bit less opinionated, which can be both good and bad. So again, like we were talking about before, it's an opinionated tool is great when it agrees with what you want to do, but if it doesn't, then you end up having to spend a lot of time just implementing things your way in a lot more verbose way. So the prevalence of these tools is helpful. And in another way, in that you don't have to learn a new CI platform every time you swap jobs or even think about moving to a different Git provider or cloud provider. So again, not having to relearn an entire tool suite every time you want to, swap to a new Git provider. If you care about vendor lock-in, then that's probably something that's important to you. All right, so question within a question. And I'd like to apologize for not having an inception or exhibit meme, but I did need the slide real estate. But the question's a good one. So let's assume you do want to go with Cloud CI. How do you choose between all those? And again, 30 minutes, we're obviously not going to go into all the subtle nuances between all the different providers, even the 6 that I showed. It would just take too long. But here are some guiding questions that can help you shape how you should be researching this stuff. So first and foremost, these 2 bullet points, the first 2 are probably the most important. So you need to look at what features you need and what the price point is for them. So your default choice should be what does everything you want and is the cheapest that does everything you want, plain and simple. Now that said, we talked a little bit about the golden hammer. So how the tool we pick is going to influence our decisions later on. So it helps to front load a little bit of that planning. So think about what your ideal pipeline would look like, and then see what some of those extra features are that are available, sort of work with you in that regard. It may be that your MVP is more, is cheaper with Circle CI, but GitLab CI actually is a cheaper option for your grand vision later on. So you really gotta consider that stuff too. And then integrations, again, you can think of that along with what features you need, but you need to make sure that the CI tool that you're looking at works with all the tools that you want it to. Otherwise, you can cross it off the list. Oh yeah, I guess I did put those in there. All right. So what does it look like? Just want to give a quick bird's eye view. A lot of these tools are the same. This is just a couple screenshots of a Circle CI pipeline I built for one of my friends' little apps a while back. But again, it just demonstrates the point. On the left, you have your pipeline definition. In most of these tools, at least the ones I've used, it's YAML of some kind. And then you just specify what CI tool functionality pieces you want to invoke, whether it's saving state, running a Docker container, executing a shell command, or something like that. And then on the right side, there's the dashboard, so how you interface with the Cloud CI tool. In most cases, you have to clicky, go add your repository and and register your application so that it knows to be on the lookout, or you set up a webhook or something. If you're using AWS code pipeline, you don't even have to do that, because you can use something like Terraform, which we do at Storyblocks, or CloudFormation if you want to use that, and you can actually automatically build all of this stuff. Anyway, you don't have to really use the UI at all. All right, so again, this is by no means an exhaustive list, but it captures some of the big points, so we'll go with it. Starting with good, minimal work to get a project set up. So we've taken out the need to set up infrastructure, install an application, and then fine-tune the application, so we're able to get going quicker. And even in the age of infrastructure as code, where setting up, like, say, Jenkins is faster than it was 10 years ago, it's still not going to be as fast as, like, Drone or Cloud or the Circle CI. So it basically, Cloud CI shifts the responsibility to the provider and allows you to focus on what's important, which is your product. And again, the maintenance cost for infrastructure, it's effectively not there, because you're interacting with that side of things there's a little bit of maintenance for the software, but beyond that, not a whole lot. Another big one is that Cloud CI adoption is trending up. So that is important for a number of reasons. Circle CI is probably the most popular one I've seen, at least in the polls I've been checking. Still behind Jenkins though. So, it hasn't completely overtaken the self-hosted solutions, but having more adoption means there's a higher chance that should you run into an issue, you're not the only one and you can run off to Stack Overflow and find an answer to whatever question you had. Or if it was a bug, you don't have to go and file a bug because probably 10 other people did. So again, this plays into, it's a good trend for Cloud CI, and it's also a factor that you should pick when picking a particular Cloud CI tool, is how popular it is. Cost is complicated. So there's potentially more cost, it's potentially more cost effective for quick and simple pipelines. So the way these pricing models tend to work is they're tiered time based. So you pay X dollars and you get Y minutes of execution time. Generally, that is also modified by the type of hardware you're running on, how many resources are available. If your project's in maintenance mode or your pipeline is super simple and executes lightning fast, like the kind that Byron likes to make, then you're potentially going to be paying a much lower cost. Again, if you keep it simple, you can get a lot more bang for your buck with Cloud CI, which is a good transition to the bad, because the inverse is also true. The larger your application gets, the slower the pipeline, and in many cases, the more users you have, again, the more concurrent builds. Some Cloud CI options charge you per user. Circle CI is one of those. It's kind of a pain. All of those things will start to add up very quickly. Extensibility tends to be limited in these tools. Now, not all, but most tools don't have the same open source support that, say, the Jenkins community does. And I'm going to save that conversation for when we get to Jenkins, because I have a few good stories there. But that, again, it's kind of a crutch in this category. Pipeline actions tend to be driven by Git events. So you're a little bit more limited if you have like auxiliary jobs, or you have sort of these time-based tasks. While they are possible to do and they're possible to design with these cloud-based tools, it's not nearly as simple as using like a Bamboo or a Jenkins in the self-hosted realm. Your DSL. So you're limited to essentially building out some YAML file that describes your pipeline. The more complex your pipeline gets, the harder it is to accurately describe what it is you want your pipeline to do with this limited form. And then finally, you've got to be able to send your code and artifacts out into the wild world, which, if you're in the public sector, is basically a non-starter. We had this problem with cloud providers back in the day, where the government was reluctant to adopt them. It took adding things like GovCloud regions and a lot of other assurances before the government would even consider it. So probably going to need to see something like that for Cloud CI. Now, thankfully, I'm in the private sector, so I have stopped caring about this pretty completely, although even in the private sector, there are some legitimate security concerns you can have here. But again, it's not completely a non-starter. It's just a choice you have to make. All right, again, running a little short on time, so not going to be able to go through this too much, but just some, back of the napkin math, looking at a sample pipeline. So we've got a couple developers, average of 5 commits a day. This is a generally small project, but with a pretty slow pipeline. So 15 minutes for a project of this size. Here are some stats. We need to execute on this particular box. These are the average runtime minutes that we have. If you look at Circle CI, which again, they don't advertise these numbers super well, but because we use them, I had them readily available. You can see that this is going to cost about $345 for Circle, whereas if you were using Jenkins, and this is even more processing power just because you have to account for Jenkins master node and then some executors, far less. Again, the things The only thing I changed here is the time that the pipeline takes, and you can see that it significantly reduces the cost. And while, yes, it's a lot more than this particular assortment of Jenkins, this Jenkins doesn't scale. There's still a lot of convenience that you have in Circle here, and it's a lot easier to make the argument why you should be spending a bit more money when, when the costs are a lot more comparable and you're still getting all these extra benefits. So this is really just meant to illustrate that the time your pipeline takes and all of these other factors, again, the simpler and smaller the project, those have massive impacts on costs. Whereas with Jenkins, you don't really care as long as you're, or self-hosted in general, as long as you're not at capacity, you know, the cost is going to be the same just by the nature of how the infrastructure works. All right, so I kept talking about Jenkins, so we're finally going to get to the self-hosted options. Real quick call out to GitLab CI and Circle CI on the right. Remember, they're cloud options, but they're self-hosted too, so won't talk any more about those. Now, as a testament to Jenkins's popularity, I didn't even use the actual Jenkins logo. Everyone knows what it looks like. You recognize that face anywhere. I'm gonna skip the boring history lesson, but Jenkins has basically been around since 2005. It got its namesake in 2011 after a creative dispute with Oracle. But Jenkins is basically the most popular tool on the market, at least as of the beginning of 2020. And Jenkins is fully open source, contains a wide array of plugins for extending the functionality. And similar to Cloud CI, you can define pipelines in a file in Git. You can also do it explicitly in Jenkins itself using code or the UI. There are a bunch of different options with Jenkins. It's very unopinionated in that regard. So on the subject of Jenkins, top left, you'll see the maritime Kubernetes themed Jenkins there. This is the logo for Jenkins X, which is sort of the next generation of Jenkins, as they call it. It's the Jenkins core built with best of breed cloud native extensions and plugins and whatnot. And basically what they were trying to do is bridge the required skill gap to using Jenkins. So they're trying to compete with cloud tools, basically. They explicitly state the goal is not to replace the original Jenkins. So you should not be dumping your Jenkins classic stock, at least not yet. Jenkins X is simply another option for people who want to get going with, without having to specify a bunch of stuff. No additional plugins. You don't have to, all the defaults should work for you. You can get up and running pretty quickly. And then finally, bottom left is Bamboo. So that is Atlassian's tool. So it's one of the products needed for the Atlassian Infinity Gauntlet of products. It's a lot prettier than Jenkins, but it has fewer features and it's aggressively more opinionated. And I mean really opinionated. So pipelines are explicitly created in Bamboo. So you don't have the option to have that file in your Git repo. So if you wanted to make a change to the pipeline, it can't evolve with your code. So if I have a feature branch that changes the pipeline, it will not, there's no way to execute this new pipeline code with my feature branch. I have to explicitly go change the pipeline or make two separate ones. It's really a pain. So when talking before about how the tool shapes how you problem solve, you do things the Bamboo way or you don't do them at all. And I've seen people try to work around it and it just creates hideous messes that we had to try to clean up. But a pro for Bamboo, I don't mean to bash it, if you are using the Atlassian suite, then it integrates really nicely with those tools. So, it's more power to you then. That you can build your glove and, get all the crystals and you can complete any software project in a snap, as they say. So going to pros and cons with self-hosted. A lot of these are going to be Jenkins focused just because Jenkins is pretty boss. The first pro being the open source nature of the product. I don't mean that in the dogmatic way that you're just sort of meant to support open source because open source is good, just because. A real tangible benefit to it is best exemplified in a story. So there was a feature to a very small feature to a niche plugin that would have made my life a lot better. And if you know anything about requesting features from people, small features in niche plugins are the first things to never get done ever. So because it's no one else's priority, why should they have to? Jenkins is open source. I was able to go and make the change to the plugin myself, write some tests, submit a PR, get it through the pipeline, get it reviewed, get it released, all within like a day. I've worked for government organizations where it takes a lot longer to do that on the same team. And I see Gene nodding his head because he's with TSA. I imagine trying to get something done that fast. And this is with people doing this stuff for fun. So again, the most empowering thing for an engineer is being able to solve your own problems. And it's at the heart of what makes open source great. Easily my favorite thing about Jenkins. Again, if we see more cloud CI tools embracing sort of the open source philosophy and having a mechanism to be able to support it, I think that'll be a big game changer. But for now, with Jenkins's history and its rich plugin suite and the ability to go in and edit those things as much as you want, it makes it truly a powerful tool. Running your pipeline and your own network, we kind of talked about that already. Accessibility gap. So that's becoming less relevant since GitLab CI is available as a self-hosted option. So Circle, Jenkins X is gaining some traction. I actually don't know if anyone here is using it. I'd love to hear more about it. I've only used it recreationally. I don't know of anybody professionally using it. As far as saving money goes, it's a little bit more straightforward here since we know the self-hosted options tend to be on the cheaper side, but there's a potential to save a lot more if you have unutilized hardware. So say you're running an ECS cluster that's EC2 backed, or a Kubernetes or OpenShift or whatever. You can throw Jenkins in there. It can run executors as containers and basically use your unused infrastructure, costing you effectively nothing. If you don't have any more space, then it's simply the cost of auto scaling your cluster up to accommodate the load, which is the cheapest you can get basically anything. So talked about extensibility. Again, even if you never submit a PR for a Jenkins plugin, they're still available. Like a lot of people went and did a lot of cool stuff, so you can use them. But now we got to talk about the bad. So you're increasing the scope of software and infrastructure you're responsible for diagnosing. So again, Jenkins doesn't, like these tools, Jenkins, Bamboo, it doesn't come for free. Things will break. You have to figure them out. You have to know the tool. You're managing an entire tool. All those plugins, you have to, well, we'll get to the plugins a little later. I won't spoil it, but there's a lot of extra stuff you have to be able to do. And this requires expertise from your team. If they don't have it, you have to get them trained up on it, and it's going to cost a lot of their time. As we talked about some of those options, there's a lot of performance variance, and some might consider that good, but for me, like, I don't like when going from one competing tool to another requires completely rethinking the entire pipeline. Like going from Bamboo to Jenkins is just not. So, it's kind of a bummer, especially if you're a consultant and you end up spending all this time learning about this tool only to have to throw away a lot of that knowledge. And then maintenance cost over time. All right, so plugins, here you go. This is what a Jenkins, this is the face of maintenance cost. So this is what happens when you don't update your Jenkins plugins. You get this ugly page that tells you how out of date everything is and what the vulnerabilities are. The good news is you're not forced to update anything. It's both a beauty and a curse, but it's tech debt. Assume you do want to update one plugin so you can get some cool new feature. If you haven't been updating any of your plugins, maybe the new version of the plugin you want depends on an updated version of 3 others, and those 3 depend on 1 or 2 others. Soon you have to update everything. And updating a plugin is not hard. Like, it's just updating a TXT file, but then you got to test and make sure that you didn't break anything, right? So it's never just like updating and remembering to do it. It's you have to do your due diligence when you update, because things will break. Again, open source is great, but a lot of times you'll have new bugs, or you'll have to make changes to your pipeline to accommodate.
Or if you happen to work in an air-gapped network and don't have internet access and have to download them all manually, one by one.
Oh, that is brutal. Wasn't even considering that aspect of it, but yeah.
That'll teach you to use dependencies.
Yes. I know you. I figured I would hear something like that from you. You'll really like my last slide then. All right, so going back to what's right for you, 3 big things to keep in mind. So know the abilities and workload of your team. If you need to, and not to bash consultants, but if you need to bring in a team of consultants to set up your CI infrastructure, and because you either don't have the time or don't have the ability, unless they're also teaching you how to manage it, then you're better off just going with Cloud CI. Because again, the maintenance cost is real. It's not going to go away. You can't pay someone to set this up and leave it there and expect it not to need to evolve or anything like that. Consider the size of your project. This isn't a hard and fast rule, but generally small and simple, we saw that tends to be cheaper. So Cloud CI, easy to get going, easy to bootstrap a small team. If you're large and complex, you're probably going to want those cost savings of self-hosted, or at the very least, your pipeline is going to need some features that some of these tools just can't give you. Some of these Cloud CI tools can't give you. And then finally, get a general idea of what you want. Pretty sure this is the last time I'm going to say this, but again, the tools that you pick influence how you solve problems. So try to figure out what your pipeline should look like first before you narrow your vision with a tool. So looking at cloud versus self-hosted generally, we should be seeing a lot of commonalities in other problems we've solved. So if that's the case, do we even need to talk specifics about CI? Like, was this all just a waste? Does CI not matter? It's really just, do I do cloud or do I do self-hosted? And would you be inconsistent if you used, if you hosted your own CI, but you did it in like a cloud provider? Hoping the answer is obvious, but no. We're asking some of the same questions, but the answers are going to differ. So maybe your team can't rack and stack servers, but they know Kubernetes inside and out. So you use AWS to provision some VMs, and you install Kubernetes on there, and bam, you've got some awesome deployment environment. But your team is, your team is good at managing that, but that's where a lot of their time is being spent. And it turns out that your pipeline's really simple, and you don't feel like you need to install Jenkins and add that extra headache, or Bamboo or whatever, and have that extra headache when Travis CI would do fine. So then you just use a Cloud CI option. So again, 3 different levels, same questions we're asking, but we just get different answers. And then finally, what is the most crucial determination for using something as a service versus doing it yourself? And I would say whether that something is part of your core business. So we're going to, I know I'm a little over, we're going to go into the realm of philosophy and sort of out of the strictly practical or hardline endorsements. So your core competency is really at the heart of what you do. So it's all about finding the things you're good at and focusing on those, and letting other people that are good at other things do those things. So what's a good example of that? Well, let's say you're building an application and you need to make an HTTP call. Would you rather write an entire library that makes networking calls also you can ultimately just make an HTTP call somewhere? Or would you rather import a library that someone else built, they figured out all the nuances of HTTP and doing all these networking transactions, they figured out all the problems, and they've made that available to you? Using libraries, not the same thing as installing and running an application. But again, the focus is that what you ultimately want to spend most of your time doing is the thing you care about. For a developer, that's writing your application. Spend as much time writing your application logic and less time managing these systems that aren't really at the heart of what you do. I don't know how much time we have left for discussion, but I'm pretty sure like negative several minutes. But I will definitely be around at the end of this so we can talk.
Yeah, why don't we let Derek go, and then afterwards we can have some open discussion so we're not pinned on time.
Yep, sounds good. All right, sorry for going over. I'll stop sharing.
Great. Well, thank you very much, Ryan. Like we said, we'll have some discussion afterwards. Derek, would you like to go ahead and screen share and then introduce yourself, and we'll go ahead and get started? Thanks for joining us.
Happy to be here. Nice to meet everybody. It turns out, come on, show me faces. Okay. All right. I'm going to dovetail off of Ryan's presentation. I'm going to talk about a different aspect to pipelines. And I'm going to center in what we actually do with pipelines and what we actually do with CI tools. And that is basically what I'm going to center in on is deploying applications. And I had hoped that, okay, all right. It is what it is. Let me, all right, just a little bit about me. I'm a professional geek. I'm been a professional geek since '87, which puts me at old, but not quite decrepit yet. I was a Java geek for better part, for over a decade. I've been in the cloud since 2010. And I do a lot towards application transformation and infrastructure automation. So basically transforming applications so that they can sit in the cloud. And the most frequent question I get is, yes, I still code, but enough about me. Let's talk about discussion resources. The slide deck is on my slide share. In the meetup, in the comments section, I pasted a link to that. You may notice in this deck that there are active links. If you get this presentation from SlideShare, the links are active. I doubt that I will see that today, but when I give presentations live, I see people with cameras, and there's just no need for that here. I've also started a blog series on cloud pipeline patterns, which is in its infancy, but I hope will go somewhere someday. Agenda. I'm basically gonna do a level set, a couple slides at the beginning. I don't know your backgrounds. I just want to make sure that we're on the same planet when I start talking about application pipelines and pipeline patterns. And then we're going to get in, center into application deployment patterns and do some summary and some joint QA with Ryan at the end. I imagine, given that we're doing that at the end. Brief history of time. I've been writing CI/CD pipelines for well over a decade, since before it was really cool. Before the cloud, basically pipelines were just primarily build, and some of the more advanced customers would do deployments, but it was primarily builds and packaging. And in the old days, and I'm old enough to remember those, you guys might not, ops, typically somebody else handled deployments, and more often than not, it's bad practice, but they were doing it manually. And releases were really, really replete with bureaucracy and constrained by schedules. After the cloud got adopted, ops in many organizations got decentralized and DevOps teams formed. With the cloud, everything is software, right? Not just your applications, but what they run on. You know, software to create the VMs you run on, or the Kubernetes cluster you run on, your network infrastructure, your security policies, everything basically is software. And with that, application developers seem to get additional responsibilities. In addition to coding their applications and coding their pipelines, they started to have to take care of small bits of infrastructure code to run their applications, which is, I say that, and I look at that as a good thing because I learned for a living. But some people look at that as a little bit of oppressive. But anyway, CI/CD pipelines can handle infrastructure code as well as application code, but we're not going to talk as much about that today. Since I've been doing this for a while, after a while I had this epiphany. I was like coding the same thing, basically at client after client after client, or for application after application after application. And everything really kind of looked the same for a while. And after reading the Game of Four, or the Gang of Four book on software deployment or software patterns, I came up with the idea that, and I'm not alone, and I don't pretend to have independently come up with this idea, but there are patterns for pipelines too. All right, and I'm starting to hone in on just one of those. And the idea is to kind of make it easier to transition from application to application, or from client to client. The more we can get our script down. There are different cloud pattern categories. All right, build patterns, which we talked a little bit about in the last talk, which basically centers around taking your application source code, compiling it, unit testing it, and packaging it for deployment, whether that's a Docker image or a Java war or some sort of PyCon package. The technologies are relevant, but essentially build patterns all kind of do the same thing. I'm not going to talk too much about those. We talked a little bit about, we mentioned infrastructure patterns, which basically can be used to run pipelines that create network infrastructure, or create security infrastructure, or basically deploy serverless artifacts if you do sort of serverless programming. I'm not going to talk as much about those as well, but I am going to talk about application release patterns. All right, making deployable, which I define as making deployable artifacts available to end users. In other words, taking my application, putting it somewhere so that end users can actually use it. And that's how I'm breaking that down. What is a pattern? Just to level set, just to make sure we're all on the same planet. There has been lots of academic work regarding software patterns, and there are people who would tell me that my description here is extremely simple and in fact oversimplifies some stuff, but I'm not an academic, I'm a practitioner, and I'm boiling this down to what I consider the most salient portions of the pattern, and that is a problem statement. No matter what problem is the pattern expected to solve, give me an example of the problem so I know what you're talking about in a non-academic sense. Where the pattern applies, where you can use it, where you can't use it, an applicability statement, say that 3 times fast. What it looks like, in other words, what its algorithm is, and the consequences. And I'm labeling that as advantages or disadvantages or limitations. All right, that dovetails a little bit with the applicability statement, but there it is. Usually when I do this live, I try to make everything a discussion, and I forgot to do that up front. If I say something that is confusing, or you have a burning question on it, I'll do the best I can to deal with that in stream. Otherwise, we can talk about it at the end. So let's talk about application pipeline patterns. All right. Basically, they take build, pipeline, output, and they make them available to end users. Some of these patterns require cloud or are greatly facilitated if you're deploying to the cloud. Others don't. We're going to get into that a little bit. Basically, these can be implemented by any CI/CD deployment software. I'm technology agnostic. I don't care whether you're using Jenkins, Bamboo, Azure DevOps, the AWS suite, whatever it is, these patterns apply. The specific implementation of the pattern may differ a little bit depending upon which tool you choose, and Ryan got into that in the last talk. But the pattern itself basically is applicable to any of those types of tools and most technology stacks that I can think of. So I'm boiling down the pattern list to 4. And I understand it's probably not a comprehensive list, and somebody's going to raise their hand and give me something that I forgot. to cover in this talk, and I'd gratefully take that. The first one is the one that we've all used for decades, especially those of us who are older. Some of you young guys might not have experienced it as much as I have. It's called Big Bang or All at Once, and essentially it means basically the application has an outage, you erase the current version that's out there, you deploy the new version, you start it up, you make it available to end users. A friend of mine calls this spray and pray. Which is essentially what it is, because we're going to get into this, but while it's the simplest to build, it also causes the most outage time for deployment and potential rollback. Next one is rolling updates, and while it's frequently used in the cloud, it can be used on premises as well. Essentially, it's used in situations where you have multiple copies of your application, and what you can do is basically roll those copies out so that users don't necessarily have an outage. And we can talk about that. Then we've got blue-green, which gets a lot of press lately, and canary, which some people will have objections to how I phrase canary, but I'll reserve those torches and pitchforks for another slide. All right, spray and pray or all at once. Essentially what happens is you declare an outage, somebody runs a pipeline, it basically shuts down the application, it removes existing artifacts that are currently running, and basically deploys new copies of them. So you're going to remove version 1, put out version 2, start the application at the end. If you're really fancy, you'll do some sort of automated smoke test to give you some sort of red light, green light to make sure that it kind of works. And then you'll declare the application available at the end. All right. The big part about this that I want you to notice is the top line where the end users experience an outage when that deployment happens. One more thing about this. When you're developing new applications, this is typically the kind of deployment pipeline where people start. All right. And the reason is it's simplest to set up. And when you're first building a new application, you're concentrating on application features, right? You just want enough pipeline to be able to get you off the ground oftentimes. And so typically I look at application pipelines as an evolving kind of construct, and applications many times will start here. All right, let's look at rolling updates. Basically, not in this case, the problem statement is not only do we need to make a new version of an application available to end users, but we need to do it without downtime or with as little downtime as we possibly can. An example might be I basically ran a application that was hosted on AWS's Elastic Beanstalk product, and rolling updates is one of the things that's native to that particular style of deployment. And basically any application deployment that has multiple nodes that is considered highly available, quote unquote, that is, if one of those nodes goes down, your application is still up. That's where rolling updates can be most useful. Don't get put off by the AWS picture of a load balancer at top. All cloud vendors have load balancers. I'm not trying to say this is AWS only, but in this situation, the way this algorithm works, let's say in my example, I've got 5 copies of my application up. In a rolling update scenario, I might update the first 2, the 2 in green first, and that would mean that end users are potentially hitting a mixture of 2 releases for a while, but essentially end users are still up, then I would basically phase in the next phase, and finally I'd phase in the last one. How many VMs or how many copies you can replace at once depends basically on what's needed to support your application. So in this, my particular example, at least 3 copies are always up in any particular rollout. And I'm just, the number that you choose and the configuration, how you configure that pipeline, your mileage might vary. You might only need 1 VM up, and I've seen people just do your rolling updates 1 VM at a time from A to Z, something along those lines. Okay, blue-green, and it's primarily used in the cloud. Some of my colleagues who are real VMware pros will tell me that if you have VMware on premises, you can do this on premises too, but I haven't seen anybody really want to go down that path. The way blue-green works is, let's imagine that you've released an application to production and it's sitting in the cloud and it's happy and users are hitting it. The way blue-green works is you set up a separate copy of, say, release 2 of that application, not only just the application, but all the infrastructure it takes to run it. In my example, this is a VM-based type of deployment. So you would have one set of VMs run by a load balancer and perhaps autoscaler on the blue side in production. You would set that up quietly in an inactive state. And this is the green side of the slide. And you could set that up and do some private testing on it to make sure that you think it's gonna actually work with a high degree of confidence, certainly a higher degree of confidence than what you get in spray and pray or rolling updates. And when you're ready to cut over, it's just a DNS switch. All right, so myapp.jmu.com points to the blue side. When I'm ready to deploy, I change that entry. It points to the green side. After the time to live gets exceeded, all the customers find themselves on the new release. And the old release is still there. It's dormant, but it's still there. And the advantage to that is if somebody discovers a problem and you want to roll back, you just change the DNS entry and you've rolled back. There's no re-releasing a previous version, none of that, right? It's very quick to do. And that's one of the advantages. Now, when you're past the point of wanting to back out, the green would be active and probably has been for a while. When you're past the point of possibly wanting a backup, the old version just gets torn down. And then when you go to version 3 and you want to install that over version 2, you just repeat that pattern. Okay. Couple of terms. This pattern does rely on what's called immutable infrastructure. All right. In the old days, particularly on premise, mutable infrastructure was more common. What that means is the infrastructure is there and you just keep updating the software on it. All right. In this pattern, the VMs and the software on those VMs or the software on that cloud infrastructure that's there never changes, right? You create it again, the cloud's all software. And you're just not updating in place anymore, right? And that's what's called an immutable software. Or immutable infrastructure. Okay. Canary. And this is where I'll get some religious wars. I look at Canary as blue-green with one difference. All right. And that difference is we don't do a night and day switch between release 1 and release 2. What we do is we do some sort of routing switch where we might say, just as an example, take 2% of our production load, send that 2% to the green version or the new release, watch for errors, see if we get any complaints, do some monitoring, see how well it's doing. And then in another stage, we might say, okay, we're doing good. Instead of 2% to the new version, we're going to give 10% to the new version, right? And frequently when people use Canary, they'll use percentages because it's simple. I've seen at least one client do something a little bit more complicated and identify specific users that they want to hit the new version first. Perhaps users that have answered a survey and say that they're willing to look at pre-release software, something along those lines. When it comes to implementing something like this, one of the reasons why percentages are frequently used is that it's supported by many cloud vendors. For instance, if you're familiar with Route 53, which is Amazon's DNS service, you have weighted routing policies, right? So this kind of situation is very easy to implement. But the same thing happens. Eventually, all end users are directed to the new version, and eventually the old version is dormant or inactive. And when you're past the point of back out, the old version goes away, just like in blue-green. And essentially you have the opportunity to do some private testing, not only you internally before you start shifting production end users over, but you are in essence testing in production to some extent, right? And the advantage here is that if you put out defects unknowingly, there's a chance that you can catch it while you've exposed that new version to a small number of users. It just means a less public faceplant, if that makes any sense. Okay, now there are a couple of pieces of a pattern that I talked about in one of the earlier slides that I've kind of glossed over. So let's bring all 4 patterns into play. All right. So let's say to apply some of these patterns, if you're going to apply use spray and pray, that requires an end user outage. No ands, ifs, or buts. Okay. The other 3 do not. If you were going to deploy your application on premises, maybe a soft required kind of thing, but it's much easier to use blue-green and Canary in the cloud than it is to do it on premise. So I'm just going to go ahead and make the statement that if you're going to do blue-green or Canary, you should be backed by a cloud. Blue-green and Canary require infrastructure as code. Typically, blue-green and Canary are used by immutable infrastructure, not infrastructure that you change the content of, but infrastructure that you just outright replace and throw away when you're done with it. And we didn't talk too much about this, but a lot of these patterns, besides spray and pray, require that you have a release agnostic database. That is the blue side and the green side can talk to the same database and still function. And you can't always do that if you're going to do major database revs. It's a separate talk, but there are relational database patterns that somebody can use to actually grease the skids there and make your changes backward compatible. Consequences. Spray and pray has end user downtime, the other 3 do not. Blue-green and Canary are the easiest to roll back because it's just a DNS switch. Complexity. We haven't talked about pipeline complexity. Spray and pray is the easiest thing to get off the ground, and then it goes progressively up from there. Canary is the most sophisticated pipeline that you can build, slightly above blue-green. And I basically consider, if you have an eye towards continuous delivery, you can't stay with spray and pray because of that outage. You couldn't have that in the middle of the day. All right, further reading. I've got my blog series that I'm starting to, or there's this stack, my blog series, which I'm starting to write and fill out now. And then there was some written material over the patterns I've covered today. They call spray and pray Big Bang, but besides the term difference, it gives you a little bit more detail into some of these. And that gets me pretty close to the end. How do we want to handle questions and answers? Because I want to get Ryan back on stage. Would you like me to accept questions first and then Ryan come back, or do you want to?
It's up to you guys. If you guys want to take them one at a time, or you just want to let open the floor and see where the conversation goes.
Yeah, I like that. I'd say just ask whatever questions, because I know I'll have one for you, but I'll let other people ask first. But, yeah, whatever topic, whatever people care to bring up.
Sure. So I will start off. Derek, thanks for presenting. I do have a question about, you presented those four and you mentioned, there might be ones you're missing. Do you think that patterns are, if you were to try to grow that list, they would grow into just variations of each other? Or do you think there are wildly different patterns that will emerge for application deployments?
You caught my don't sue me clause. All right. I spent a lot of time. I've done pipelines for forever. I've been at a number of different clients. I did a fair amount of research going into this talk, and I didn't find anything besides those four. However, I'm gratefully accepting if somebody raises their hand and wants to point me to a fifth one. I would be more than happy to take a look at it, and I would be grateful for the suggestion.
Yeah, just because they, even when you look at these, and you mentioned it, right? You start off with do it all at once. The other end is the canary, where you slow roll it across, and then it's variations in between. It doesn't seem like there might be, just like the Gang of Four book, which were, not that there aren't other patterns out there, but these are the core ones that show up time and time again. It seems like that might be the four that are going to show up time and time again, at least now.
Now, where you're going to run into differences, all right, I'm seeing a lot of serverless development in applications, not just old style hosted kind of workloads. All right. So each of the cloud vendors handles serverless differently. All right. So if you've got serverless components, that'll happen in your infrastructure code, and that'll be either blue, green, or canary. And I don't think you would have, I can think of ways you could do it on the Amazon side. On the Azure side, I would be struggling to figure out, if you had a serverless function component, how you could effectively do a rolling update. So you are going to get some differences in the physical implementation, right? And in fact, if I showed you a blue-green deployment on the Amazon side and on the Azure side, their first glance would be, well, are these even similar? Right? Because the clouds are just different. But I'm kind of abstracting that away, right? Even the Gang of Four pattern book, they use C as examples, but they make it very clear that they don't care which programming language you're using, right? So,
yep. Okay.
I hope that helps answer the question.
Oh, it does, absolutely. Ryan, you said you had a question?
I'll let other people talk. I'll wait at least a little bit.
Yeah, I was going to jump in and say I've definitely seen these before, and what I've seen is just some variation in some of them. So the canary will go multiple different directions. There'll be some people that go to the percentage, like you were saying. Other people, I've seen presentations where they'll use feature flags. And so they'll either have like a header in the HTTP header that somebody can set inside of their application so that they can call in and get the new version or not. And you know, all kinds of different abilities to decide whether or not you're going to the canary build or not the canary build.
Right. That is actually a good point. Basically, the term I use for what you're describing there is called a feature toggle. All right. And the reason I didn't include it is because it's not really a deployment pattern. It doesn't affect your CI/CD pipelines, right? Those are the same. But what a feature toggle is, and I can give you an example if you want to go down that road, is it basically you put a new feature in production with the toggle that allows you to control from the outside whether that feature is available or not. All right. Yeah. And it kind of goes along the same lines as Canary in that you are testing in production, right? Yep. You're just your end users, your production users are in effect your testers. And the best example of that is when GitHub wanted to change its algorithm for figuring out differences between source file versions. They were really scared to do that. They had some tech debt on the old one, and they were really scared that people would just be irate if they switched it out. And they were so scared that they implemented the feature toggle that you're talking about, right? So what would happen is when you pulled up a source code difference, it would give you the old tried and true results. And in the background, it would figure out whether the new algorithm matched the results of the old algorithm. If it did not, somebody got an email nastygram reporting the defect.
Yeah.
So
yeah, the other scenario I've seen a lot, just because I work with containers so much, is that they'll have a lot of containers. They won't deploy just one feature. They'll have all kinds of groups doing independent development of all kinds of stuff, and they'll just have a container out for each feature. And I think part of the challenge when you get into this is that you really need to focus on how you're monitoring your deployment, because just saying here's how you're going to deploy only gets you halfway there if you don't have a way to monitor it and know whether or not you're getting a better result or not.
That is an excellent point too, for Blue Green and Canary especially. You don't necessarily want to wait for customers to call in and complain that you've gotten something wrong.
Yeah.
So good questions. Thank you.
I feel like I didn't ask a question though. I was just kind of throwing out comments. But yeah, definitely like we were saying earlier, the for you list is the same for that I've seen everywhere else.
I had I guess a general question for the group, but in like the rolling updates, the blue greens, the canaries, what are some good strategies or paradigms for handling the database? Because typically if a developer makes a database change, you want, hopefully it's like an additive change, or if they're subtracting stuff, then you do it in a way where it can be backwards compatibility. But granted, you can't watch everybody at every single point. So if a mistake does happen, I guess I'm kind of curious of what strategies people have implemented besides the typical rollback.
That's a very good question, and I didn't have time to get into it. But there is actually a book that was written in the early 2000s that I thought should be a bestseller. And I don't normally promote other people's books, but it's database refactoring patterns, and I'm spacing on the guy's name. I've seen it before, but he goes through and he catalogs about 100 different patterns that you can use to refactor your relational database and make it so that a database can be usable by release 1 and release 2 in many cases. So,
Was that Kirievsky? Is it Joshua Kirievsky?
no, it was some Canadian dude. I will take a note to look up the book reference and post it in the comments in the meetup section.
Yeah, you see me moving my green screen. I'm pretty sure I have it on my bookshelf somewhere back here. I can't get to it right now.
I think in my team, personally, in some of the teams at my company, it's not universal across the organization because there have been a number of acquisitions, but I think we would usually try to avoid having a database, an application rely on a database in a way that any of those kinds of changes or pitfalls that you could run into in a deployment would happen cross team. So the teams are responsible, we're not building we're allowed to use cloud services so that we're not building all our own stuff, but anything like that, we try to, like database access, we try not to provide certain kinds of direct database access unless we know there are, certain guarantees around it. Otherwise, try to keep it behind an API. And then the other thing is trying for other kinds of data interchange, trying to work with formats that are designed to evolve. So protobuf being the big example. And we have in our one of our merge checks for some of the protobuf content, it will do there's a tooling that I think Uber released that you can compare 2 different Git commits of protobuf, and it will tell you, have you made an incompatible change either in the underlying format or in something that will cause incompatibilities when they run the code generation, even if the underlying binary format is the same. And so we don't let those things merge without, if there's, for, I don't know, whatever reason it absolutely has to, that means, oh, we need to do a lot of communication around this one in particular. But usually that's, if we can avoid it, we just try to stay away from that. Although I know you can't always.
Right. And I'm not trying to say that by going with more of the complex application deployment patterns, you can skimp out on your unit testing or your integration testing. You certainly can, right? All of that is still in play. So whatever you do to keep code quality up, to ferret out mistakes before things go out, I would still do. So.
All right, and Derek did post. It was Scott Ambler posted in the chat there with the refactoring databases book. So excellent. All right.
One comment I would make on specifically needing a cloud provider for, I think it was for Blue, Green, and Canary. One really cool thing you can do with Kubernetes, depending on the ingress controller you have, which controls external traffic coming in. If you use something like Istio, you can set up weighted routing policies, but the key thing is that you're not doing the switching at the DNS level. You're doing it within Kubernetes, so it's a Kubernetes construct. Typically, you'll have like a legacy, or not legacy. You might have like a beta URL, and then there's like the prod URL. But you can then send certain traffic to the prod URL. You can do like 50-50, 90-10, whatever. But you can do blue-green. I mean, you could have your application running on Raspberry Pis, and you could be doing blue-green deployments. So it's one of the really cool things that containerization, and specifically container orchestration tools, has allowed us to do.
That is a good point. In fact, Kubernetes specifically provides rolling update supports for deployment workloads, and you're absolutely right in that internal Kubernetes magic can handle some of that.
Yep.
Absolutely.
Yeah, and I mean, with Kubernetes, rolling deploys become the default, whereas before, like with VMs, you're right, spray and pray is like kind of the default that you get. And once you start getting into container land, you're kind of upgraded a little bit. It's pretty nice.
Agreed. And I didn't get into Kubernetes at all, but
Yeah,
you're absolutely right. And if I'd have had 15 more minutes, I would have put some material in for that. But you kind of go with what you have.
Yeah, I didn't realize how hard it would be to cram even just a small amount of content into 30 minutes. It's definitely a challenge.
Yes, been there too many times. Yeah, moving it to load balancer is definitely, instead of DNS, you get a lot more flexibility when it's in some kind of load balancer, whether it's Istio or Nagios, or take your pick of all those. See a lot. The other thing I've seen with Blue Green is I've seen at least one of my customers had a production and stage environment, and the stage had pretty much everything that was going to production. It was just the one that wasn't active right then, and then they just flipped them. And so they were going to have those two environments already. It was on-prem. They had the hardware for both those environments. And so it was no big deal to just flip that switch and go back and forth between the two. And so that was how they handled their blue-green.
Right. I think I issued my don't sue me clause when I got into blue-green and got into what required cloud and what didn't. And I think what I did is I softened that up to basically said it's much easier to do it in the cloud because everything's software than it is to do it on premise. I guess I'm still feeling that way, but I understand why you might not quite agree with that.
I definitely see the underlying premise for that. I'm just spending a lot of my time in containers. Some of that advantage that you get from going to the cloud, you can see a little bit of advantage just by having a container orchestrator in front of your workload. Yep.
Fair point. I feel like I'm robbing all the question time, Ryan. Do we have any questions for Ryan?
I did want to ping and say, we've seen Jenkins out there that has their very DSL-ish syntax. And so you've got, you're doing Groovy, you're doing whatever you're doing to write your pipelines in Jenkins. And then it seems like everyone else is doing some kind of YAML/container syntax, where they've got the definition and you're going to run everything in a container and here's your structure. And at least the ones that I've seen some of this stuff with Drone, and I've seen Circle CI and a few of these other environments. And so I'm curious, are there other designs for CI systems outside of those two? And if not, is everything going away from that DSL design because everybody kind of seems to hate Jenkins that I've talked to?
Yeah, there's especially at Storyblocks when I joined, everyone there is really the one thing everyone agrees on is that they despise Jenkins, and they're all ready to go to Circle CI. I don't know. Jenkins still has a special place in my heart. I do think even in whether you're using scripted or the declarative syntax with Jenkins's Groovy, I think you do end up getting into a pattern of kind of like what the YAML tried to simplify, which is I have steps, and a lot of the times it's just running a container to do something. And I think it's a bold but probably a smart move that Cloud CI has taken, and that they've just fully embraced that. I think and again, I think it is a little limiting. To your question, I don't know of another pattern, so I'd be interesting to see if anyone has heard of one, but it's also kind of hard to imagine. Like, you have a structured YAML, or you have sort of an imperative program, and I don't know of any other options.
Well, I know Azure DevOps actually has a graphical builder that you can use, but then it translates it into, I think it's a YAML file on the back end. So you can still do it in YAML, and you can switch back and forth between them. So it's not like with Jenkins, if you decide to use the UI, then you're not using pipeline as code. And if you go pipeline as code, you don't get to use the UI anymore, right? It's all or nothing. So it's kind of nice that you can switch back and forth.
I'm not sure if it's another pattern or not, but I've had a couple of clients that were using one software flavor of CI that had dreams of getting into another software of CI. And in fact, they wanted to go from Bamboo to Jenkins. And so the way they were going about it is they were attempting to buy themselves some insurance. So in other words, the pipelines themselves were just incredibly simple. And they would write bash scripts or whatnot that would actually do the logic. So for the CI tool, it just executes a bash script with a bunch of environment variable settings, and that's it, right? And the bash script handled everything from there on out. And the idea was that that would just nicely move into Jenkins when they were able to pass Jenkins and get it.
Yeah, I've seen a lot of people that made their company DSL on top of the Jenkins DSL, you know, just went an extra layer of meta just because Jenkins was so flexible and you could do so many things with it that you needed some structure.
Yep.
Yeah, some of the guys at my client actually have a library that they use so that it ends up being essentially that. It's all declarative syntax pipeline code in Jenkins, but they, you know, if they're building a .NET app, they call like one function that says build a .NET app and here's the name and the URL and that's it, right? Everything else is done in a standard-ish way.
Yeah. And again, like with small projects, if you end up building a DSL that's, you know, someone else has already done, like, because you're not doing anything special. 9 times out of 10, you're not doing anything special. Someone else has thought of it before. That's why a lot of times you can just get away with, if you can handle the price, you can just get away with Cloud CI. But I've seen, like, I don't know if you remember Pecos, Gene, but a project I had a couple of years back, I mean, we had a pretty sophisticated, like much better than Jenkins's, what was it, their declarative pipeline. And it was just not that the declarative pipeline was bad, but we had some special needs for our special client, and it was just nice that we were able to do that. Whereas if it's just never an option, sometimes you end up getting burned by it.
Do you ever feel like going with the cloud options or the YAML driven options? Does that drive you closer to homogeneous pipelines than some of the more flexible or the self-hosted ones, or it doesn't really work out that way for you?
So, I guess not entirely sure. For me, the more I've used Cloud CI solution, like the more I've used Circle, the more I've come to realize that I took Jenkins for granted. And again, I tried not to make my slides too opinionated. I was hoping everyone would come away hating everything equally. But like, again, the open source nature of it, like with Circle CI, I remember I wanted to do something super simple. And it was something like only running certain commands if it was a pull request. On Pecos, like I mentioned before, it was like 3 lines to do that with Jenkins. And in Circle, it was like, there just wasn't a way. And I go and I look at like ideas.circleci.com, and there was an issue where someone was requesting that thing 2 years ago. So I, frisbee my laptop across the room and basically gave up. I found a way to like hack it in. There's like some environment variable that was there. It just felt dirty, but I don't know. There are a lot of cool things you can do with Cloud CI. I really like to be in control of everything. So
I mean, I think there's a good argument to be made that the flexibility is nice to have, and I think there's also a more often a good argument to be had that not having the flexibility is a good thing in a lot of environments.
Yes, the Yagni principle,
Yeah.
And I do like that, and I don't know. There have been too many times where I've been burned by it. Now that said, I think Cloud CI, and that's what I tried to convey, is like Cloud CI is probably right for a lot of people. Again, if you can handle the money, that's the big thing. I don't pay the bills at Storyblocks, so I'm not putting up any fights at our use of Circle CI. But
yeah, I mean, one thing you didn't put into your calculations too was you do have to pay. There is somebody maintaining those boxes, right?
Yeah.
Even if they're cloud boxes themselves.
No one important.
No one important, right?
Yes. Yeah, no, that's true. Again, that's why I tried to make it known. It was just simple back of napkin math, but there are a lot of other calculations. But again, yes, the guy that has to maintain that stuff at Storyblocks is me. So you're right. That guy's time doesn't matter.
Absolutely no one important.
Yep. That's $0 worth of concern.
When you're using self-hosted stuff, are you terraforming that, or is that was something we ran into previously, like with our Jenkins server?
Yeah.
It accumulated so much state,
Mhm.
and it was terrifying to try to like back out of that.
So yeah, so for Jenkins, depends on how far you want to back up, but I would initially say no. What it's backed up with is Kubernetes YAML files, or if you want to get really fancy and use Helm charts, and then you have like these extensive like either Groovy scripts, or you can have, there's a configuration as code plugin that allows you to like configure all of your plugins when the container starts up. And then of course with the Jenkins Docker image, there's plugins.txt, which makes sure you have all of your plugins. So I don't know that, like, we would use Terraform to make sure the cluster exists, but I wouldn't even consider that part of Jenkins. It was just, we have a cluster, and then the Jenkins stuff is just all Helm / Kubernetes YAML magic. And there's some voluming you might have to do, like the Jenkins home directory, which there's a debate as to whether or not you should do that, because it allows people to make changes in the UI and have them persist when you'd rather it not. Then it also keeps your job history on restarts.
I guess not even necessarily Terraform, but any way to like force that into version control, even if it's a slightly roundabout way. It was just
then yeah, it's just a repository with all of your either a customized Helm chart, or on one of my contracts we had like our Jenkins image was completely customized, and we did some cool things in there. So it was completely automated bringing it up, but it wasn't at the Terraform level per se, because the cluster already existed.
We've done it a couple times where we've used like Chef or Puppet Ansible, something like that, to control standing up the boxes.
Yeah.
And then there's some plugins for Jenkins that anytime you make changes to the configuration, it'll automatically check it into a Git repository and force you to comment it and everything. And the nice thing about that is now even though there is some configuration state with the Jenkins cluster, you also have it all checked in as code anyway, and recreating it's not Terraform easy or Kubernetes easy or like a Helm chart or something, but it is, if someone blew everything away and you had to go back to scratch, it would all come back quickly enough, everything but the history of the jobs.
So like
that said, I've been running Terraform pipeline or Terraform infrastructure as code pipelines for through CI/CD tools for at least a couple of years now. I manage that just like applications, so I'll have infrastructure pipelines to set up Kubernetes clusters or.
Did we lose him or me?
Wrong time for the connection drop.
Yeah.
Okay.
I think we lost Eric there.
Yep.
Yeah. Give him a second.
Yeah, I would say for me, a lot of it is that I'm working in environments that are not ready for, they're not ready for Docker, much less Kubernetes, Helm charts, that type of stuff. So, we're.
Yeah, I've been on my to-do list is to have the drone CI environment on my little home lab deploy the drone CI environment. See if I can do a little inception there.
Nice. I'll have to fish those memes out again.
Yeah, on the and maybe Derek was about to talk about it, but I was curious. Oh, Derek,
Hey, he's back.
We got him back.
And he's muted. You're muted, Derek.
That's still muted.
Can't hear you.
He can't hear us either.
Oh,
No,
here we
there he
go.
is. Okay.
Here we go. What I was attempting to convey was that essentially I look at infrastructure pipelines just like any other kind of pipelines, right? CI/CD tools aren't just for applications for me, they're for infrastructure. I use them to run Packer pipelines to produce golden images. I use them to run Terraform to create complete cloud environments from the ground up. All backed by source code, all using the same practices that we use with application code. So
Yeah.
I guess I don't see the difference that you're pointing at, is I guess what I'm saying.
I guess one clarification I would make is that, so we use Terraform to create the clusters. I guess my point is like the Jenkins lifecycle. If I wanted to make a change to Jenkins, I'm not necessarily recreating the cluster every time. It's like I can create a new namespace in Kubernetes that like sets up all my DevOps tools, and like it's a complete clone of Jenkins. It's got all the plugins, everything. So it's like that maximal level of configuration as code, and I can do my devy stuff there without worrying about breaking prod. But again, it's just the pipeline for Jenkins itself, and to get those changes deployed, I don't have to muck with the Terraform at all. Though, like you mentioned, it is backed by Terraform at the core, like the cluster is brought up that way. But just the Jenkins stuff, you know, all Kubernetes and Helm driven. So yeah.
I was curious if anyone had any experience with the, like, some of the Terraform Enterprise stuff. I don't know that my company would ever. I don't know. We have plenty of other things we need to pay for first before we do that. But
all my clients use whatever they're using for CI/CD, whether it's Jenkins, Bamboo, Azure DevOps, or the AWS suite, whatever they're using, they use that for Terraform. They already have the skill set, right? It nicely fits in. It's backed by source control. It nicely fits in with everything else they're doing. Why use a new tool?
So like one of the things from the Rust environment that I haven't, like, I know there have been various open source versions. Well, I mean, so the thing is open source itself, but it's been tailored as a tool for the Rust the Rust language repo, is Boris, which it watches commit messages, and when a commit is approved, it is like proactively bundling PRs together and then running a combined testing, and then if there are any failures, doing the bisecting to figure out who was the bad apple, rejecting that one, and then merging the rest. And I think that was kind of one of the features that looked compelling with Terraform Enterprise, is a similar lifecycle like that, so that I could say in my repo, like, hey, this looks good, like whether I directly approve it or I just give a hook that it's looking for, and then it then goes ahead and rolls all right, I'm going to try to run this for you. And if that fails, I get rejected. If it succeeds, that's now merged into master, because that's what's in production.
Yeah. The thing I would worry about, maybe Terraform Enterprise has an answer to this, but I'm pretty dogmatic about visually inspecting my Terraform plan results before the apply goes. Right? Because it's not necessary that somebody made a mistake in their Terraform code that actually errors it out. It's that Terraform code, that we've got a right-hand, left-hand problem happening somewhere, and you, if the plan goes, you're deploying changes that you didn't intend. That's really what I would worry about.
I mean, I think I could be wrong, but I think part of it is it will print out the plan in the PR, but I could be wrong about that.
Right. I guess what I'm dogmatic about is that somebody actually looks at that plan before the apply happens. I've just been burned too many times.
It's a powerful tool. It'll mess stuff up quick. Yeah. I don't have experience on the enterprise. I've got coworkers that have, but I'm blanking on all the good features they like about it.
It's a good sale.
All right.
So if we're at a quiet spot, I can always throw in my rant about Jenkins.
Go on.
All right.
I've just been burned by it twice, and so I was saving it to the end because it's not a question. It's just general rant. But I've been burned by it with the plugins and the versioning once, and that was you get into the famous DLL hell that we're all used to way back in the day with Microsoft. That still exists today with Jenkins with plugins, because you'll get a plugin that needs the newest version of Jenkins, but you'll have 3 other plugins that have not been updated and need an old version of Jenkins to work, or they'll have interdependencies between themselves. And so you need to update a plugin plus a dependent plugin that goes with. It just gets complicated really quick. And then you update something to fix one problem and you break 3 other things in the process that you didn't even realize you were breaking. So that's my one burn. The other burn, I was at a client that made the news multiple times lately, in not good ways. And they had a Jenkins cluster that was deployed by one of the big 4 or 5, how many consulting companies do we have out there nowadays, after all the mergers and everything? One of the big consulting companies I won't name, and a big client that I won't name, had gone in there and deployed Jenkins and needed access to all their coworkers, consulting coworkers that are out somewhere to access Jenkins instance. So they just put it on the internet. And then a short while later, they were running a Monero miner across their entire AWS cluster. So yeah, I've been burned by it twice. I was brought in to help them secure the environment. And that was the first thing of, this should have never been on the internet, 1, and 2, upgrade it. Stop running really old versions of Jenkins that aren't patched.
Yeah, upgrading Jenkins is a full-time job. Luckily for those on the call that know me, I compulsively update my own software. So for me, I get a great sense of pleasure out of going in and updating and testing the plugins. So my Jenkins I tend to not run into that issue as much because it's kind of my favorite tech debt to relieve. As for, that is interesting. The nature of Jenkins or CI tools in general is like you kind of give them the keys to the kingdom, the more things you want them to be able to do. So yeah, if Jenkins is public, it's not good. Yeah. Kind of like when you're like, you have a bunch of different services and you have a bunch of different passwords for them, but you have one password data, like if you use KeePass or LastPass, so you have one database. So if somebody gets the password to that, it's very, very bad. And it's somewhat unavoidable. I mean, you need that feature, but so like Jenkins, you need Jenkins to be able to do all this stuff. But then when it gets compromised, yeah, you're hosed.
One of our coworkers, Rich, always points out that Jenkins is a remote code execution engine, right? That's what it does by design. So anytime you put it out there in the internet and don't lock it down really, really strongly, you're just asking for trouble. Yeah, and that really brings back my previous question on, is there DSL and there's the YAML container solution and other patterns, and the one that I wasn't even thinking of is not CI, but to use like a GitOps pattern where you're doing a pull from a Git, and the Git repo has controlled who's allowed to merge, multiple keys on there. And then since it's doing a pull, you don't have credentials in your Git to push into your production cluster. It has to pull from the Git to deploy something. So there are other solutions out there, but yeah, Jenkins really does have the keys to the kingdom. I've been there many times. Yeah, and it's like Ryan said, the more you want it to do for you, the more permission you give it, because of course you will, because it's the pipeline, right? Why not? Yeah. Root on every system, access everywhere to do deploys. It can do anything.
It's easier that way.
Yes, it is easier that way.
A huge key that I found, though, is that the operations team needs their own development Jenkins instance for them to test those patches and updates and things like that. Yep. I've seen way too many times when they want to try something out and they update the Jenkins instance that all the developers use, and they kill all the developers because there was only one Jenkins out there. And so then they become paranoid and they never update because they knew that last time they updated, they broke it. Mm-hmm. And so that's how you get the 3-year-old version of Jenkins out there.
Yeah, that's why the pattern I was describing earlier with bringing up a separate Kubernetes namespace, installing all your DevOps tools there and testing. I don't even know how people did it before that. It is a real game changer.
Yep. All right. Everybody's dropping. I'm hogging the conversation.
Oh, I'd been talking a lot, so I was trying to sit on my tongue for a little bit. As I like one of the things that seems like I mean, it's still cloud-based, but it feels like it could have the same kind of rich like plugin ecosystem as GitHub Actions. I don't know how much you've played with that. I've started to like be like, oh, this looks neat, and then it's like, oh, this is a very deep ocean that I am walking into, and I just wanted to like, you know, wash my hair or whatever.
Yeah.
But it looks like I guess it looks like it has a very positive potential for being a, you know, easily sharing workflows and tool sets.
Yep, we've just started using GitHub Actions, and yeah, from what I've seen so far, like we use it to build some base database images, but like it's super cool. I definitely want to figure out all the possibilities and the way you can rethink your entire pipeline with using those. As usual, GitHub, the best Git provider, objectively speaking, is leading the way there.
Is it different from the model that I've seen with like the Circle CI and the drones and other ones where you've got just the YAML and running everything in containers? Because the little bit I've seen, it looks similar, but I'm curious from people who've tried it.
Oh, okay. So I didn't know if you were going to say something, Scott, but so for me, the way we use it, it's actually keyed in on when you modify certain files, it does certain things. So again, there are other triggers for it that are, I guess, that allow you to do multiple things in the same repository, as opposed to, I think I mentioned it in the talk, where like the model of just having the file that describes your pipeline that gets executed when you commit, it's a bit more sophisticated than that. And again, we're using it for a very small use case, so I don't know. There could be a bunch of drawbacks, or there could be a bunch of really cool things you can do. I haven't discovered it yet, but from what I've seen, it seems a bit more flexible than the model we've been working with.
Yeah, like one of the things that I need to investigate is, and that would be really helpful for our team, is that if we're, at least for things we have deployed in production, we're using a monorepo. It's a very small team, but like I drive the Python like data analysts and scientist guys crazy when they're building Rust stuff on every single like release and vice versa. And it's like, there's no reason this needs to run. We made no changes, but I've looked through CodeShip documentation and I don't know how to tell it to be like, hey, you can just check, like, these are directories, and if nothing changed in there since master, like, there's no need for you to run that again. But like that feels like the kind of thing that would be very doable. I haven't attempted it, but it feels like the kind of thing that might be very doable with GitHub Actions.
So more featureful, but otherwise, other than just having a whole lot more knobs and tweaks and options in there, it's still the container design where everything is running inside of a Docker container in theirs, or is there other stuff outside?
I thought so.
Yeah, the execution, I guess, yeah, if you're talking about like what you can do within the action itself, yeah, I think that's meant to be the same. I don't know that it's any more flexible beyond that, but I think the part that was lacking with Cloud CI was kind of different triggers. Again, the way I've dealt with that problem before, where it's like you have actions in your pipeline that you really only need to do if certain files were modified. It's like, yeah, I could check it, but I'm just going to suck it up and do this every time anyway. And now you don't really have to. So, you know, is it a huge game changer? I don't know. Probably not, but I also don't know yet. So it'll be interesting to see.
Just having all this stuff in Git,
yeah,
GitLab
I guess,
where all our code is already.
Yeah.
Just the accessibility of the control flow that you're running those containers in, and the filters, I guess seemed like the biggest thing that was promising. Like it was, again, CodeShip example with doing the testing against the master protobuf branch to make sure we hadn't done anything backward compatible. There's no way for CodeShip to also pull down any other branch than the one that it's testing. So you need to like give it special permissions to be a different kind of Git user to go back and clone your repo, even though you already just shipped it, your repo. Like that was, that was aggravating. You have my repo. It's like, no, we don't. No, we don't. We have this one snapshot, and there is no way for you to give us anything else.
Ugh.
Except as like a more general purpose bot.
Mm-hmm.
So.
Yeah. Sounds like an ass.
I was curious, Ryan, do you how, to what extent where you've worked has most of the DevOps job been centralized versus like federated to the teams?
Okay. So you mean like having the core DevOps team versus like empowering people to sort of own their own process? Probably more.
Or like embedding a DevOps like specialized software engineer.
I've seen both, like both at the same time, where there is the core DevOps team, which I think does kind of make sense, and that they sort of own it. I don't know. I've gone back and forth on this. I think it makes sense to have people that own like sort of cross-team functionality. So there's a lot of infrastructure that no one team would necessarily own. And so and there are also people that are like champions of DevOps. And then maybe you have a DevOps representative on the team that tries to help the team own their own process. At Storyblocks, they're doing one of the better things I've seen. DevOps is still an emerging pattern here. Just from what I've been able to, I haven't been here super long, just a couple months, but like it's still an emerging pattern. And what we have is like there's the core DevOps team, and then there are people on the teams that are sort of in charge of, like, they do normal development, but they're the people that know how the Terraform stuff works. And ideally you get everyone able to do it, but the fact that they have teams that are able to do the whole thing themselves is, I think, a step in the right direction. So, but I think a lot, especially with larger organizations, people just slap the name DevOps on their ops team and give them some new tools, and that's about it. Which is unfortunate, but I mean, I don't know, it's also to be expected. I mean, people do that with Agile.
We installed Jenkins, so we're DevOps now, right? Or do we need to install Docker too?
Yeah, that's people view it as a tool. I know Byron doesn't really have any thoughts on like Agile or DevOps or anything, but
just blanking here.
Yeah, but a lot of times it's really just changing some terms around and calling it a day. But not at all places. So I don't know if that answers your question, but some places do it better than others.
Just all becomes a water scrum fall.
Yep. Yeah. Well,
Yeah,
hey,
we're like.
Yeah. Well, if you've.
Sorry, go ahead.
We have Scrum Masters, and we break things down into sprints, and we call our status meeting a stand-up. So we're basically Agile. Yeah, that's all it takes.
We're like we previously had more as a smaller company, had more centralized things than than was good for us, and it showed, like, and I don't know who decided it, but of course we needed our lab full of our own hardware, and
right.
We would get told like, hey, we can't, this thing is unusable, it's like 4 times over provisioned. We'd be like, oh, we're gonna add more servers to it, and it's like, well, it's only 4 times over provisioned right now because everybody has stopped putting stuff on it because it doesn't work. Like, and we're seeing like weird edge cases in Docker, like timing issues that nobody's ever seen before because of how slow it is. And then, yeah, it would be like, well, yeah, it's just a container and the demand is gas. Like no matter how many machines you put on it, people will be like, oh, this thing works again. Great. And then just start running stuff. So yeah, we moved to then like, no, everybody gets their own AWS sub account. We got a lot of like help with like people championing like Terraform and like Spinnaker, although that didn't get as widely adopted, but like, yeah, so kind of got help with like some of the tools around that stuff. And then that's sometimes frustrating, but I've found that much better. But then we were acquired by a much larger company that has a waterfall background. And so their sense is like, well, if you're going to write a microservice, here's the like 500 Java files that you start with. And then I don't know how many. I'm exaggerating because I don't write Java. But and then yeah, obviously you go to our giant Jenkins server and like on-prem like everything, and we see the like comment threads in Slack about, hey, is Jenkins down? We're running so many jobs on the master node, it's not able to, like, we're like, oh no, please, like let us stay in our own little bit of misery, managing our own fate for as long as we can. But
yeah, that
I don't know, we're a small team, and so we definitely like, yeah, we're a small team, and so we definitely see the burden of needing to manage our own stuff. But then it also is a very compelling motivation to go with like, okay, let's go with Fargate and like other things that handle a lot of stuff for us. And it's not where our biggest spend is in like Presto. So like the like niceties of saving some of that DevOps time is, you know, like just pennies compared to where we actually spend our money. So
yeah, Storyblocks.
But
yeah, we love Fargate as well. It is one of our favorite things over here. It actually is. It's an interesting hybrid because, you know, you're not running the infrastructure, but, you know, you just specify some containers and you specify how many resources, and boom, away you go. Super expensive though.
yeah, like, yeah. Every time I look at like our AWS costs, I'm like, oh, it seems like we're really like over provisioned on that like, I don't know, Airflow job scheduler. And then it's like, no, like Presto, our Presto cluster is still like 95% of the team's cost. So like, what's the point of tackling anything else?
Yep. That's actually, we have a similar thing where S3, because we're a stock media company, so S3 is our primary cost. So whenever anybody talks about optimizing costs in other areas, they're just like, S3 costs X amount of dollars. Who cares about this other stuff? And it's like, well, okay, I mean, you're not wrong, but we can still optimize a little bit.
Yeah.
It's funny. This was good, Gene. A lot of good discussion.
Yes, thank you very much for presenting, and thank everyone for hanging around and discussing. It's as I mentioned earlier, and we talked about a little bit at our first meetup last month or earlier in the month, just that it's really nice to try to, for me anyway, to try to have some sort of actual meetup part to the meetups instead of just being presentations. So I'm really glad people have hung around and had some discussion, because I really do miss the opportunity to discuss with people that isn't directly related to whatever work I'm doing. We lost the water coolers, we lost that too. So thank you very much. So, all right. Well, the plan is to have another one. Tayo said he'll talk next month, and I'm looking for another speaker. And then, so hopefully I'll see you guys back here next month.
Cool. Yep. I'll see you all then.
Thanks a lot, everyone.
Hosting.
All right.
No problem.
Nice to meet
See
you all.
y'all. Bye.